Thank you for attending this Vaniman webinar on aerosol control. I am Nathan Fry and I'll be your presenter today. So who is Vaniman? Well, we're an American company with some humble beginnings. Our founder, Ed Vaniman, used to visit dental offices and labs and ask if he could help to solve any problems. After that, our first product was made back in 1985, a unit called the Accumulator, which ended up launching the company. And Ed's legacy was basically building products that are easy to use, easy to maintain, and long-lasting. And it's been a part of our mission to utilize our 35 years of air filtration experience to improve the lives of dental healthcare professionals by building products that solve problems. So here's what we know about dental air quality. The U.S. Department of Labor ranks the dental profession as the #1 and healthiest job. And this is basically due to airborne hazards. So what sort of hazards are the primary sources? It would be aerosol generating procedures, patients and staff sneezing, coughing, breathing in general, transmission of biological aerosols, chemicals that you'll often find in dental labs especially, but also some dental offices such as monomer, zirconia, mercury, daily exposure to disinfectants, and everyday environmental particles such as dust, mold, and allergens, which also increase sneezing, coughing, and breathing, etc. So research has showed us that aerosols are in fact the biggest threat to dentistry. And out of all the procedures that are done, scaling produces the highest amount of aerosols. Now, specific to COVID-19, a study that was performed in Nature essentially found that 46 to 55 out of every 100 COVID-19 cases were actually contracted by pre-symptomatic carriers. So it's important to know that pre-screening patients, it helps, but it's not often a guarantee of safety. So aerosols are basically any sort of suspended particle that is under 15 microns in size. And there's a wide range and variety of contaminants that all negatively affect the air. The important thing, though, is that the human eye can only see down to about 50 micron. And it really is all about what you can't see that has the most danger and presents the highest concern for dental. So how do aerosols travel? We have a nice little chart here from the CDC that kind of illustrates the range of different transmission particles. Please note that dental aerosol generating procedures will travel up to around 6 feet. And once they hit the air, they tend to expand and remain in the air for up to 3 hours on average. After that, particles will typically deposit on surfaces, countertops, the rug, etc. And they can be stirred up if foot traffic goes by them, if AC vents turn on. Pretty much any sort of airflow source will store those particles back into the air if they're not captured. So how do we effectively control these aerosols? Well, there's 3 primary methods. We have source control, source capture, and air exchange. So source control, this is where we're using things such as masks, face shields, surface disinfection procedures. These all help to reduce or lower the contaminants from the actual source itself. But mind you, this doesn't necessarily remove the contaminants once they're airborne. It's only mitigating the risk involved with it. Our next method is source capture. This is where we're capturing contaminants at or near the source and then removing them from the air. There's a couple ways to do this. The first is through extraoral aerosol suction devices. These work to capture escaping aerosols in the general area and capture them within the HEPA filtration. This is a type of multi-source capture, and what I mean by that is they'll protect the staff from the patient. They'll also protect patients from other patients by capturing aerosols in the ambient air. Again, it's drawing the air into the device rather than towards the patient mouth. And they have the added benefit as well as adding additional room interchanges in the operatory. So the other option is high volume evacuators. So these capture the aerosols that are generated intraorally. And this is really a single source of capture. So it will protect the staff from the patient. However, it doesn't offer any ambient air protection. And it's actually, if you think about it, it's drawing the air from the environment into the patient's mouth, almost like a funnel. So that's why it's more of a single source of capture system. Source capture equipment, our solution is the Vaniman Vanguard Mobile. It is a culmination of over 20 years of air filtration engineering design, this particular unit. It's the only extraoral suction that's been clinically proven to reduce aerosols, and they're actually presenting on that unit in the lectures today. It's quiet, so there's no added noise during procedures, and on its own, it's about 53 decibels, where a saliva ejector, for example, is around 67 on average. It's hands-free operation. Again, it's like a RDH's best friend there. Made in the USA, and the retail is only around about $1,200. Has a flexible hose system that allows capture really around 360 degrees to the patient's mouth. So air exchange is the third method of aerosol control. This is where we're removing the air contaminants by filtering large volumes of air. So HEPA air purifiers are one way of doing this. These capture airborne contaminants throughout the office and operatory air, reduces the wait time between patients by removing those aerosols. Other options are HVAC systems. However, these usually offer very little air exchange. In fact, on average, around 1 to 2 air exchanges is what they average. And most commercial systems aren't able to actually add a HEPA filtration filter into it because it limits the efficiency of the system. The other option for control is UVC light fixtures. Now, these can't be run when you have staff under the light, and it should be noted that it requires very specific dosage of light, specific airflow, and takes a long time for it to really be effective. So that's why we typically only see that being used in hospital isolation rooms. And again, I have a highlight here for the current CDC and ADA guidance, and essentially what they're saying is you should wait at least 15 minutes after completing any dental treatment before the next patient can basically be seen and you can start the disinfection process. Using a air purifier will actually cut this time down. So as far as air exchange equipment, we have our Vaniman solution, which is our Pure Breeze HEPA air purifier. It's got a really nice 4-stage HEPA filtration system, captures the air, and additionally, any contaminants that might be in the room or operatory. So it does offer 4-stage filtration, and it's portable and quiet and made in the USA. And MSRP on this unit is around $1,800. And here we can see a picture of it actually installed in the operatory. So next up, we have the obligatory PowerPoint quote, and it's from the US National Library of Medicine, and it basically speaks to the efficiency of any in-room air cleaner. And what this essentially is saying is that units can be ineffective if they're not properly placed, and that's important to note. So in other words, you can't just place it anywhere. There's a few factors you have to consider when you are placing these devices. So what that is really a large focus on the air changes per hour, which is key for when you're talking about aerosol control. I have up here on the slide, you can see a formula for calculating ACH, but essentially what it's doing is using the CFM of the device you have and measuring that against the air volume of your room. Here's a little nice comparison chart that you'll see where we compare different device CFMs, and you can really see how the ACH is affected when you start increasing the room size. It drops pretty significantly for most units, so that's why having a higher CFM rating is really more efficient. On the right chart here, you can see a chart that's from the CDC, and this is for their guidelines of 99% efficient aerosol removal in various dental settings. Open operatories, for example, is 6, where if you have a closed operatory, it's up to 12. The optimal placement for these systems is typically in or near an operatory, if possible, in waiting areas, high traffic areas, underneath HVAC system intake ducts is another option. But essentially what we're talking about is to get closer to that contamination source would be the best. And again, if you need any assistance with this, we have online calculation tools at our website that can help you calculate this. And all you need is your dimensions and your CFM. It's pretty cool. You can check it out. I wanted to add a few points here on UV light and sort of the stuff that no one is really talking about when it comes to dental. So UVGI is what's referred to ultraviolet germicidal radiation. It's been around for a long time, and it's commonly used in hospital isolation rooms, sometimes overhead fixtures. But to work, it requires a high enough dose of radiation to actually kill the microbes. Now, bacteria and things like that are actually pretty easy to kill, but viruses, for example, are highly durable and actually require a higher dosage of UV on average. But here's the thing. These systems aren't really recommended for use inside filtration devices, and this is basically based on CDC recommendations. And the reason why is that air filtration is, these devices have a very fast airflow, and it's often too fast for a sufficient dose to be applied. And not to mention, there hasn't really been any scientific proof or studies yet to prove their efficacy inside a filtration device. But don't take my word for it. Here we have a couple of studies and a top researcher, Dr. Richard Korsky, actually, who's a dean and a fellow at the International Society of Indoor Air Quality and Climate. He suggests to stick with HEPA technologies that are proven, basically avoid add-ons. And if you look, there's been a study done in 2005 back when SARS-1 outbreak was occurring, where they actually wanted to test the use of UVGI inside HEPA filtration. And ultimately, they concluded that it was inconclusive. So basically, the benefits were not really there with the devices. So, is aerosol capture and air quality really important? What's really the future of all this? Well, there's a lot of benefits to it. A lot of it is staff and patient perception, which is really important. Flu and other airborne infectious diseases are always going to be a threat. It also promotes better air quality overall, which really what we're talking about with that is better health for staff and patients, right? So it's lowering people getting sick, less allergens, stuff in the air will actually improve productivity. As you can see, I have a little stat here from OSHA, and they estimate that like $15 billion a year in sick leave and poor work performance is the cost of poor air and indoor air quality. So if future regulation or stay-at-home orders return, if you're prepared with using these systems, you'll have a faster return to work. You'll be ready to meet any sort of CDC requirement, and patients can continue to their treatments, with confidence, knowing that their health is being taken care of and looked for by the dentist. So one final plug I want to get in there. Please visit us at our website. We have tons of great information about infection control products, our air purifier, our extra oral solution. Also, lots of great detailed articles with latest research and tips for air quality and control. Anybody who's in need of masks too, we have a really good supply of those that are FDA approved. So it's pretty good pricing. So please check that out. Happy to send anybody references. Just enter your email and your name in the chat, and I can shoot those off.